yesterday is because we didn't finish summarizing this. So we're going to do that now. Oh, I just mocked you late. I'm sorry.
They'll fix it in the office.
Okay, problem yesterday was about population growth. Can a population also decay? Yeah, so we are going to write a basic formula for both of those. So our exponential call it, we do growth first. A of t equals A of 1 plus r to the t. Does anyone remember what A was in our original problem? Don't remember? It's a good thing you probably wrote it down. Yes, always going to be our initial value. Our 1 plus r, I think, Michael, you asked me this question yesterday about why we added it to 1. Yep, this is our growth factor. T is the time, which most times we have in year. R, all by itself, is called our growth rate. So that's what we were adding to 1. And we always want this as a decimal. What do we think we call A of t? If t is our input, A of t is our, output at the end. Now let's say I had a decay. That is going to change our 1 plus r to 1 minus r. This is now called what, Sunny? What do you think this is now called?
Decay factor?
Yeah, decay factor. Natalie, what do we call the negative r right here then? This r. Yeah, decay rate. It's the only difference between the growth and decay models is that we're changing the negative r. So I write it out fully. A of t equals A, like that. Okay, we're going to do another practice problem up on the boards with this from yesterday. Very similar, except you guys can do it all on your own. And you got to decide if it's growth or decay. These are going to be groups, which you already saw. So find your people. 8 will be on this board because we're going to have group 8. Yeah. Do you just need the decay part? Yeah. Okay. Find your groups. And then I'll give you a problem once you're up. The solo energy. The groups are on the walls. 2 is in the back. 1's up front. 3 and 7 are on the doors. 8 is this. It's only because of them. They're so big.
You pointing here? Kind of.
This guy.
I assumed that we never had 24.
Yeah. I'll give you a white board in a second. Okay, group one. You're welcome.
I feel good. What are you doing? Say big. Stuff notes maybe. All right. Oh, no, that's it. I'm just kidding.
Marker's fine.
Marker?
Expo marker.
So initial value 58. That's initial.
Yeah, 58,000.
Increases. So decay rate. Each year, we're in. So I'm guessing like without everything, we.
Then we're gonna move on to the next topic. It is, you can look on the backboard. It's up there. Or ask the person next to you. They probably wrote it down. Okay, 6.1 is done. We're going to move to 6.2.
Sweet.
Yes.
You want me to erase?
Yeah, if you want to. Mark, that'd be great. Thanks, Mark. Okay, we're still talking about exponential equations or models. So when we talk about models, we kind of mean equations or functions. Let's do a little warm up. Similar to what we just did. Does anyone invest in here? Sonny, I'm looking at you. Because you do. Yeah. Yeah? Okay. Sonny, you're going to be the topic of this conversation today. Sonny. Invest. How much do you want to invest, Sonny? Let's do higher than that.
$3.
Not $3. 66,000. Okay, that's a lot of money. You invest into what? How do you spell that? Okay. D-O-G? D?
D-O-G-E. X-O at the end.
D-O.
Okay.
Okay. It's gonna, that pays, or has, a 4% annual interest. I want you to all, with the part next to you, write an exponential growth or decay function of this equation. Very similar to what we just did. Amy, am I growing or decaying in this problem? Yeah. I'm earning interest. So, Amy helped us all out with that one. Okay, this should only take you like 30 seconds because we all just did it. What? Yeah. Write it down. See, the person behind you also has the same answer. 1 year? Now, what if I want it for like in 20 years? What can we call that?
When you're writing here, only look here. Like it won't. You don't have to touch a button. Like if you hover above it, you'll see the mouse. Like hover above it, just don't touch the thing, and you'll see if you get close, the mouse goes, and then it's just the whole screen. Only look here when you're writing, and it's just normal. Just keep looking.
What's my input? Add to this equation. Okay, equals a t. Where do I need to put my exponent if it's an exponential growth? Yeah, after the parentheses, right there. Perfect. Okay, so after 3 years of studying investing, how much will he have at the end? 3 years. So after 3 years, how much does Sunny have? So what variable am I plugging in 3 for?
The T.
Yep, the T.
So we would get $74,241.02 for.
I love it. Can you say it one more time so I can write it?
We would get $47,241 either 2 cents or 24 cents.
I love it. I'm gonna blog. All right, now 47. 74. Got you. 74 to 41.02 because it's money. So round it to the nearest cent. Now, what if I said I wanted this monthly or quarterly or bi-weekly or weekly? What would have to change in this equation? T. Yep. So this is also called compound interest if I'm doing it not by a year, but I'm doing it like multiple periods in 1 year. Do you want me to scroll up? Yeah, okay. So this is called compound interest. It's interest upon interest. Does anyone know the word compound interest before I even said it? Have you seen it before or heard it before? Yeah? Okay. Compound interest. Formula. Do you guys know the famous penny problem for compound interest? No? Okay. You guys want to play Would You Rather? Okay. Would you rather have a penny that doubles every day for 30 days? Or would you rather have me give you $1 million right now? Okay, penny doubles, or who wants $1 million?
Only over 30 days.
Just over 30 days. You only get a penny that doubles for 30 days.
So you get 1 day is 1 cent.
Yes.
Next day
2
2 cents.
cents. Next day you only get 4 cents.
So that's only 30 days.
Only for 30 days. Or $1 million right now. Okay. If you want the penny that doubles, go on this side of the room. If you want the $1 million, go on this side of the room.
Oh no, Michael, you're cheating. I don't want it. It's like common knowledge.
No, wait.
Come on, you gotta go with me. I know what I'm talking about. Guys, I scammed you. It's only $22. After 30 days.
Oh, for 30 days?
Come on. You double. Think about it. 1, 2,
No,
4.
you're wrong, Jenny. It's for 30 days.
Okay. Talk amongst yourselves about why, and then pick one spokesperson.
I just really like.
If you know the answer, don't say the answer. We're enjoying it.
Watch them walk over here.
Okay, who are spokespersons for our groups?
Oh, chill.
You can pick multiple too.
Yeah, I watch YouTube channels.
Okay, my $1 million group. Tell them why you want $1 million. Oh, don't look at. Okay.
Let me ask you this question, guys. Is life certain? Do you wake up every day thinking you're gonna be awake for every day? Think about it. Think about it. The next day you might die. So, you know, get $1 million. But you get the $1 million. Just going up with this. No, but like in 30 days. Yeah, but that's in pennies.
Oh, you can see that.
So watch, I'm gonna fly.
Damn.
Now try to get the big number in pennies. That's in pennies right now.
Okay, don't do the math yet. We're not doing the math. Just talk about would you rather.
I'm not gonna carry like a million pennies on my pocket. We'll be doing that.
Okay, my penny side. Why did you choose pennies?
Okay, I'll go. See, I chose pennies because every time I chose the $1 million, I was wrong.
Okay. Anyone else have a better reasoning? I'm sorry, Lily.
Also, if you think about it, it doubles. It's not, and it goes over a period of 30 days. So if you just get handed $1 million, a lot of people are irresponsible with that. I would be one of those people, don't worry. And so it just doubles, and then you have more money by that. What?
Okay, I need a volunteer. Who wants to volunteer and show us? Nobody wants to. Okay, I guess no one's gonna get candy.
Oh, I'll do them.
Okay, then get out there.
Me?
Sunny, what? One day, you have 1 penny. The top line is $1 million. Increase it to 5 days.
Where?
Down below.
Oh.
Drop the dot down below. Yeah. Okay. Okay. Million group, you guys still have $1 million. My penny group, you have 16 cents.
Not really. I mean, I could invest the money. Alright, I could go stop.
Keep going.
I could gamble it.
Oh, that's
10 days. Okay, you guys have $5.12. You guys still have $1 million. Okay, Sunny, go to 20 days. Speed it up. Okay, you guys have $5,242.88. Still very short with money. Keep going. Any way you want.
6 of them. Oh no. All right.
What did you get? 20? Yeah. So at 30 days, how many
Oh.
pennies do you end up with? 5 million pennies. So you guys are what, by about $4 million.
It's $5 million USD.
Okay. I would have picked the pennies. Yeah. So. Okay. Compound interest is interest upon interest. So when we went to 2 days, we had 2 pennies. The next day, we kept doubling that to 8 pennies. Next day, what is 8 times 2? 16. So it's interest upon the interest, which is so much better. Let's go back. Yes. So now you all know what compound interest is, right? Yes. So compound interest is an exponential model. That's used to calculate interest. Lando, you writing? Okay, this is the formula. A of t equals, say A of 1 plus r divided by n. That's the new bit in this. We're adding an n because there's multiple periods within one period. So A of t is still our output. A is our initial value still. Lots of times they're going to call this the initial principal also. What is my R? Do we know? How much did Sunny invest? 4%. So that is our annual investment rate. Annual interest value. T is still time and is still our input. Also could have been called an argument. That's where we're plugging in our values to. Okay, new thing. The new thing in this equation is our n. This is the number of compounded periods in a year. So how many months are there in a year? 12. There are 12 months in a year. So if I was talking about years in this thing, we would put, if I was talking about months, we would put 12 here and 12 here for n. And we're going to do that with Sunny's example. Sorry. Keep going up? Okay, I'll give you a second. Okay, taking Sunny's problem above, I want you guys to find the amount. How many did we do? 3 years? Okay, 3 years if you did it monthly and quarterly. Okay? I'm going to draw a little table for monthly and quarterly. We already found yearly, so let's start with yearly or annually. Wake it up. So we did annually already. Compound interest formula. I'm going to put here. Just doing a 3-column table. And this is the amount after 3 years. So let's say he gets a return every year. What was our equation? We already did it above. Kennedy, can you read it out to me? Our equation for our warm-up. Yeah, I'm just going to write it like this right now so we have it separate. And we had 1 year, right? So it was just 1. That's why we kept it like that. So time, we had 1 year. What was the amount after 3 years, Kennedy? What was the amount after 3 years? 74? And 2 cents. Great. So this is from warm up. Okay, let's do quarterly next. How many quarters are there in a year? 4. So like in school, you have quarter 1, you have quarter 2, you got quarter 3. Normally in a year, it's like about 3 months long each quarter. So if I was doing it quarter, what number am I changing in this equation? Yes, our denominator, which is Rn. What should it be, Angel? Yep, 4. And then figure out the amount after 3 years. And then try monthly.
Would you plug it in with T?
6, 8, 6, 7, 9.86.
Why did it decrease? I thought 220. Show me how you do that.
Four times 3. Okay, yeah, that's your exponent. Not that. That means you put in 4t. Yep. Look at this one. So 1 plus 5. So this there should be an amount after 3 years. So 3 years. There should be 4 times. What are we plugging in for t for each problem? In for t. 3. So we should be plugging in 3 for each one. I'm going to write my monthly, see if you get the same equation. we get for quarterly? How much money? $45. Did we already do monthly? No? Okay, did anyone get monthly yet? Yeah, Michael, what did you get? 0.94? Wait, is it increasing or decreasing? Why is it increasing? Yeah, do you want to explain that a little bit more? Okay, compound interest, but like the penny problem. We're doing interest upon interest. So you get more interest if you do compounded interest for a shorter period of time. So it's like you get paid $100 now instead of $1,000 in the future. You can get interest on the $100 now monthly than in the future. Okay. What is the monthly growth rate and the quarterly growth rate for these problems? Look back at our definition we started with today. Go from there.
Still.
Which one's your rate though? Yes, this whole thing. So divide it by 4. Same thing for monthly. Yes, it's a little bit less than the year, but it's still better. Okay, I'll give you one more definition for the day. What? Want to do weekly? We can do weekly, yeah. Angel wants to do weekly. How many weeks are there in a year? Yeah, 52. Why 36? Okay. Weekly. Amy, what should my N be again? Yeah. Yes, 52. And mount after 3 years. Let's see.
Friday, because it was 1 minute. We did not have leap year. So it's February 29th.
Isn't it every 4 years? So many times.
Okay, sorry.
Naomi got a bigger value. Naomi got 74,411.36. Do we agree? Yes. Okay. Sonny wanted to do daily. Daily. Mark, what am I changing my N to now? 360. Yes. 1 plus. Because we have 365 days and 1 year.
I have leap year shouldn't. If we just added 1 minute to the end of Friday, we didn't have to add leap year. We didn't do that. So, that was the first 4 people. We don't actually need to. We just add 1 more minute to every leap year.
Then it would have just been March 1st. No, we just shouldn't have even done leap year and had a leap day. We don't actually need it. Just add a minute to a Friday. Make Friday a minute longer. It'll be fine. What do we get?
Yeah, 24 hours in a year, that's right.
Say it again.
74414.32.
Yes. It's still increasing. It's just by less now. From annually to quarterly, there was a big jump, but it's getting smaller and smaller because it's exponential. Curving up a little bit steeper. Okay. Homework with 6.1. Oh, I should stop this.